Well, here's the third scenario where a projectile is being launched from a height above ground level and then dropping below where it started. In that situation, it's a little bit more complicated because now we have a displacement which will actually be negative if it drops below its starting height. So I have this set up at a 65-degree angle, launching at 18 meters per second. Launch, freeze immediately. And you can see here, there's the overall velocity. And here is the velocity broken down into components. There's a horizontal component, which is calculated by multiplying 18 by the cosine of 65. And the vertical component is found by multiplying 18 by the sine of 65. And that's how you break the overall velocity vector down into its two components. So you can see here that the whole time that it's rising, the vertical component is dropping, it's getting smaller and smaller, and then finally turning negative, and the horizontal component never changes. So let's continue that on, and there we have impact. Well, if you want to find out what is the time to hit the ground, there's two ways you can do it. Number one, you can use the quadratic equation. You can put in the v1, which is 18 sine 65. You can put in the, and that would be positive, you can put in the acceleration due to gravity, which would be negative 9.81. You can put in the displacement, which would be minus 10. And then you would have to use the quadratic formula to find the time it takes to hit the ground. Now that's, that could be more work for you or it could be less work depending on how easy you find using the quadratic formula. It's just as easy to find out the V2 at impact. Use your V1, which is the 18 sine 65, the acceleration due to gravity, which is negative 9.81, the displacement, which is minus 10 because it's below your starting point, and you can use that to find V2. And once you've got V2 in the vertical direction, you can put it into V2 equals V1 plus AT and find the time it takes to hit the ground. And in this case, it will come out to be 3.85 seconds. So I think it's probably the same amount of work, but you have more information if you do it with those two steps. With the quadratic formula, I don't know. Like I find that there's a lot of places to make mistakes, but you will get the same answer no matter which way you do it. And I think that's pretty much it. And then if you want to find the range, well, all you have to do is multiply the time in the air by 18 cosine 65. And that's going to give you the horizontal component of the velocity, which is constant, it's never changing. It's moving sideways at the exact same rate, multiplied by the time in the air, and you'll get the range that way. So oops, I had this paused. There we go. Moving sideways at a constant rate, 29.32. So that must be equal to 3.85 seconds multiplied by 18 cosine 65. And that's about as hard as the problems get with these projectile motion ones.